So hello guys, today we are going to work on our Go code. Yesterday we did some iterations and array and some slices. So today we will, I guess we can see if there is still something to do on the slices, and then we will move on to the next part of the tutorial. Like, I don't know what's the next step in our Go learning, but we will see. I see that next step is structures, methods, and interfaces. Okay, good program. I don't think we are gonna do like 3 hours like yesterday. It was kind of a lot. So maybe let's see this slice thing where we were, and we will see what we can do today. Let's go. Okay, this is not so. I don't know why it's like that. But never mind. It's fine. Okay. Okay, so where were we? Yeah, I remember we had a little struggle with this example thing at the end, but I was very, very happy because we had this function working. Like, we used the spread operator. Yay, I remember the name. That's great. So yeah, we had some tries with that. So we use this function with some slices in parameters, and then we passed some parameters into our summal function, which were waiting for also some slices in parameters. And so we did kind of a good job, I think. I think it's even better than the tutorial. So I'm just having a look at the tutorial to see what we miss without following it, really. But I think we're going to be fine with that. I think so. So checking quickly. Yeah, okay. Type safety, blah blah blah. Okay, I think we should be fine with this example. We have covered arrays, slices, the various way to make them, how they have fixed capacities, arrays. But you can create new slices from old ones using append. Oh no, yeah, okay. Slices have a fixed capacity, yeah, okay. Length to get the length of an array or slice, test coverage tool. It's not written here, but I think we also use the deep, what was the name again? Deep equal function. Very, very useful function, I think, for the future. Let's see. Okay, so check out the Go blog post on slices for an in-depth look into slices. Try writing more tests to demonstrate what you learned from reading it. I don't remember if we checked that last night. Maybe we had a quick look. And another handy way to experiment with Go other than writing tests in the Go playground. Okay, you can try most of the thing out, and you can easily share your code if you need to ask questions. I have made a Go playground with a slice, blah blah blah. Okay, here is an example of slicing an array and how changing the slice affect the original array, but a copy of the slice will not affect the original array. Yeah, it's a question of references, I think. So yeah, interesting, but I think we should be fine with that for now. Okay, yeah. Okay, so let's just have a quick look at this blog post. And then we will move on to the structure part to do some coding. Yay. Okay, so where is it? Yeah, here. Go slice, provide a convenient way, blah blah blah. Okay. So some understanding about arrays, slices. Okay, len and cap function for the capacity, the length. For those who don't know, the length is the total, is the length of the element, the number of elements in the slice, I think, and the cap is the capacity, so the how many elements you can put in the slice, I think. Slice internal, one variable, blah blah blah. The length is the number of elements referred to by the slice. Okay, the capacity is the number of elements in the underlying array. Okay, it's a bit different from what I said. Distinction between length and capacity will be made clear as we walk through the next few examples. As we slice S, observe the changes in the slice data structure and their relation to the underlying array. So we have this slice with 2, 4. Slicing does not copy the slice data, it creates a new slice value that point to the original array. Oh, okay, I see. Okay, so if we do a slice, it's not gonna like take those two and copy it somewhere else. It's just gonna point to these two parts. Okay, so you're not, in fact, you're not creating another object, you are just doing a reference to another object. Yeah, that's pretty clear. So I think this article is very interesting to read, to have a look in depth, but to be honest, I think I'm not ready to read it tonight. Like, yeah, I'm a bit tired from my network configuration, so I think I'm gonna skip that for tonight and come back to it later. Maybe tomorrow or another day. So let's go for the structure course. Let's have a look. So you can find all the code for this chapter here. Great. Suppose that we need some geometry code to calculate the perimeter of a rectangle. Okay, some geometry. Interesting. Given a height and width, we can write a perimeter function where float 64 is for floating point numbers, like, yeah. The Tdd cycle should be pretty familiar to you by now. Yes, that's right. So first I'm gonna create a new folder. I'm gonna go to the only code for now. Let's create a new folder. How can we call that? Structure, structs. Yeah, I'm gonna call it struct, and then we will see if we need to rename it. Structs. Okay, great, it's not in the right place. And now it is. Structs. So I'm gonna go with my terminal also. Structs. Yeah, perfect. Okay, so seems like we are gonna do some geometrical stuff. So let's create a file called something like shapes test, as it's our test file. Remember, we are going to write the test first and then make the test pass, make the test fail first, then pass by writing some code and iterate through this process. So let's write the test first. Okay. So Here we are. Package struct. So we're gonna write this function test perimeter. We said that we want to float in parameter like width and height. So let's go with width as a float 64 and height as a float 64 also. So maybe we can write that in another way like that. I don't know what the good practice is for that. I kind of like that for now. We'll see later if we have any other way to do it. Any better way to write this. Okay, so here we are. Remember, this is not our function, so I made a big mistake here. I'm sorry. This is not what we want to do. I'm gonna keep that for later. But what we want here, in fact, is a test object. You remember, like testing the T. I save and I don't have my import. I don't know why. I could have this testing import, but it's not. So okay, I don't know why. We will see later, probably. Function test perimeter. And okay, so what we want is, in fact, that's good because I already wrote that. So what we want here is to call our perimeter function, not test, it's just perimeter, like that. Okay, okay, and now it works. It works. Great, great, great. So here I don't want width, I want something like 10.0. Remember, we are floating here, so no integer, we just putting some float. So this is gonna be a square. Okay, width 10, depth 10. Okay, so I want that. And oh no, sorry. No, that's not what I want, that's what I got. What I want, in this case, is the sum of all sides of this square. So 10 by 10, it's gonna be like 40. What we want is 40.0. Remember the dot 0 because we want floats. Okay, and then the traditional if got is different from want. Then what I will do is call the t.hero f, and I saw in the tutorial, I'm not omniscient, so I saw in the tutorial, and the syntax is really close to the C syntax, and in fact all the syntax in formatting things. To have a float, like we put the float, and 2 to have the number of numbers after the comma, the point in this case. Okay, so yeah. We did not got, we just got. Sorry. Okay, so here we are. So same thing here, like 2f. And then the first one is what we got, and the second one was what we wanted. Okay. We are fine here, I think, for this test. So let's run it and see that it fails. Go test. Oh, crap. It's failing. So now we are, as always, gonna write the minimum function to make it pass. So I'm gonna close that and that. And I'm going to create a new file called shapes.go. This is our main file. So package structs. And here we are gonna write the function perimeter. And here we're gonna put our parameters like width and height, which are both some float 64, like that. Okay, so this function is like that. And remember that it should returns float 64 also. Okay, so what we want is a parameter. So in this case, as it's a rectangle, what we're gonna do is return 2 by width, 2 per width plus 8. Okay, so we just add the 2 sides and make it twice, and I think we should be fine. So what is the should have comment or unexported blah blah blah. Okay, let's add commands. This is the linter, so it will compile if I try, but yeah, it's just to make this prettier. So, I mean, I guess we should make it prettier. So perimeter is gonna compute the perimeter, the shape, of width per 8. Okay, so now we have a comment, and it's not even fine. Comment on exported function parameter should be of the form perimeter. Okay, sorry. Perimeter computes the perimeter. Oh, that's a surprise. Perimeter. Here we go. So let's run the test. And it passed. That's great. Okay, so I think right now there is nothing to refactor. So we can go. Yeah, I mean there is just one calculus. So come on, guys. And we are gonna go to the next step. So far, so easy, they say in the tutorial. Now let's create a function called area that will calculate the area of the rectangle. Okay, so let's go for the Tdd cycle again. What we want to do is write a test function like test area. Okay, this is a testing function, so the testing t. Here we go. So here what we got is area of, let's change. Yeah, we can change bit. Fine, 0. And what do we want is the area. So just 12 per 6. In this case, we are gonna have 72.0. And then I think I'm just gonna copy that. Exactly what we want. Check. And that's it. So, should we make it fail? Yeah. Let's do it. So, what it's saying is that we have an undefined area function. Or at least area symbol, because I'm not sure it understands that it's a function. We'll see that later when going into the compiler. But not tonight. So let's go and create this area function right now. Okay, this shouldn't be so complicated. You're a little familiar with geometry, like area, width, okay. And this is still some float 64. We are also returning float 64. And we're gonna return, in fact, just the product, both width and height. Yay. So I'm just gonna copy this. We have a beautiful code. It's not the perimeter, the area of a shape. Yeah, perfect. So let's run the test and it should work. Yay. Okay, so we're fine also for the refactoring in here. So let's have a look at the tutorial a bit. I'm gonna share that with you. Here it is. Our code does a job, but it doesn't contain anything explicit about rectangles. Indeed, yeah, indeed. An unwary developer might try to supply the width and height of a triangle. Yes, of course. But yeah, I mean, it can happen sometimes. This function, without realizing, they will return the wrong answer. Yeah, okay. So we could just give the functions more specific names like rectangle area. Yeah, of course. A neater solution is to define our own type called rectangle, which encapsulates this concept for us. And here we go. We are in the structure part. Okay, we can create a simple type using struct. A struct is just a named collection of fields where you can store data. Okay, so kind of a classic concept, I guess. Declare a struct like this. Okay. So I think I should put that in the code part, like in the implementation. Wait a minute. Yeah, it's not perimeter here, it's area. So I'm gonna define this struct. I think, I don't know where, but let's try. I feel like doing it here. Rectangle. So it's struct. And we're gonna declare, oh crap, the width, which is gonna be a float 64, and a height, which gonna also be float 64. I guess we could do the same as here, but I think in a structure it's more clear to have it separated like that. Splitted, okay. I think it's my opinion. Okay, so now we are going to refactor what? The function? No, because we used test-driven development. So let's change the test. Okay. So just a second. Let me grab some water and I'll be back in a minute. And here we are again. So let's continue that. What were we trying to do? Yeah, we need to refactor these methods in this function, these test functions here. I cannot wait to understand properly the difference between function and methods in Go, because I really don't like to try saying something and it's not the right word. I usually really don't like that, and I need to, because I don't know the definition right now and I don't want to learn too fast, so let's wait for the tutorial to explain that to us. Okay. Okay, let's go for this refactoring. So instead of having these two values here, I'm gonna change that and try to add just an object, which will be a rectangle called rectangle. Not rectangle, but rectangle, yeah. I mean, okay. Where did we call? I'm gonna do the same thing for this area thing. Rectangle. And oh, surprise, it's not passing at all. We have both errors here because there are two different tests. Okay, so okay, so let's change this. Okay, so what we can do here is change these parameters, I guess, like that, and put some rectangle, which is of type of, which type is rectangle. It's not like I'm just gonna put some dumb comment here. I'm stressed by these yellow things. This is a rectangle shape model. This is a model, in fact. Okay, so here we are just gonna change this by rectangle dot width and rectangle dot height. I didn't had a look at the tutorial before doing so, but I think I'm pretty confident about that. Yes, with capital letters, of course. Yeah, I think it should work, right? So let's try to run the test. It's not. It's not. I don't know. I don't know why. Why is this not working? Oh, oh, sorry. I didn't create this variable rectangle. Okay, I'm so sorry. Rectangle equals, like we affect a rectangle type having, oh no, I just checked the tutorial, yeah. And it's not like, it's much like that, more like that. Sorry. So here we had 10.0 and I guess 10.0 also. So here we are fine. And then here we have the same kind of rectangle, just with the little one, equal to rectangle. And here we add 12.0 and I think 6.0. Yeah, 72, so we're fine. Why is this not working? Yeah, because we didn't implement that in area function. So I'm just gonna copy paste this. Okay, and put this here. And I'm just gonna do that like that. Okay. Good. 8. Here we go. Yay. It's working. So I mean, we should be fine with that. Okay, I hope you will agree that passing a rectangle to a function conveys our intent more clearly, but there are more benefits of using struct that we will get onto. Okay, fine. I totally agree with that. Our next requirement is to write an area function for circles. Oh yeah, I see where you're going. But I mean, we will see that by ourselves. So just checking that the stream is going well. Just 1 second. And yes, it is. Great. So let's continue that. I'm just gonna move that, and that's it. Let's go. So we want to write an area function for circles. I think they mean that we want the area function to be able to compute rectangles, but also circles. So in order to do that, remember what we're gonna do. Yes, this thing here, like subtests. Subtests. So this one will be for rectangles. Okay, so we are gonna write a function taking this parameter .t, and we're gonna put everything in here. 1 second. Yes, like that. Okay, we are just going to check that it still pass. I mean, we don't want to. Okay, perfect. Okay, we're fine with that. And t.run. T.run, and here we are gonna write the same thing for circles. Circles. Okay, so here again the function with the t arguments for testing, t for test. I would love to make some t-shirts like t for test. Okay, let's go. I feel like I forgot something here, but I'm not. So, okay. So here we have our circle, which will be of type circle, I guess. And for the circle, I think we're gonna give it the perimeter, or the perimeter, sorry, the radius or diameter. I don't know. So let's put some value. We will see. It's not an issue here. Got what we got. What have we got? Like area of circle. Okay, and what do we want? We want this, so yeah. I'm gonna take the value of the tutorial. Like, oh, this is a pretty high value. Okay, I'm just gonna copy paste it. I hope you don't care. I could have like compute that in my head, but not so cool. So I'm just copy pasting it. And we're gonna have the same thing here. But okay, the tutorial is saying to us that if we use the exact same thing, we're gonna have some issues because I mean, let's try like that, and we're gonna see the issues. Okay, so let's try to run the test. The build failed because we don't know the circle type. So let's create a circle type. Okay. This is gonna be a type with name circle. Gonna be a struct. Struct with what in it? Probably the radius, which gonna be a float 64. And that's it. We have our circle type. So let me take this comment and put it here. Okay, we are fine, but it's not a rectangle, it's a circle. Of course. So we run the test again. And this time we cannot convert 10, which is of type int, to type circle, because I fucked up. Probably. Yes. And you didn't tell me. I don't like that. Okay. So let's run the test again. Cannot convert 10. Or is it? Type float to type circle. Yeah, and it's not parentheses here. Yeah. I'm sorry. Be fine. Yeah, perfect. So now we cannot use circle of type circle as type rectangle. So yeah, of course. So this is where it's bad because we are going to have the same issue as we were talking about yesterday. I will show you the tutorial. Do you remember when I was talking about overloading yesterday? And we have the same issue here. Exactly the same issue. Because if we want to do like we did, we probably should write another method called the same way, but with a different kind of argument, with a different type of argument. So we are not going to be able to do that. So I think we are going to use some interface, like the I-shape interface. No spoiler, but I think we're going this way. Let's see. But you cannot in Go. Yes, we know. Area redeclared in this block. Yeah, we already tried that yesterday. So we have two choices. You can have functions with the same name declared in different packages. Oh crap, that's no, that's not good. So we could create our area circle in a new package. That feels overkill here. Yeah, totally. We can define methods. Oh, here we are. The method things. On our newly defined types instead. Okay, so we are not going to talk about interface, but methods. And this is another method. This is another way to do it. Okay, so what are methods? So far we have only been writing functions, but we have been using some methods. When we call t.errorf, we are calling the method errorf in the instance of our t. A method is a function with a receiver. A method declaration binds an identifier, a method name, to a method and associate the method with the receiver's base type. Okay, maybe. Methods are very similar to functions, but they are called by invoking them on an instance of a particular type. Okay, I got it. Where you can just call functions wherever you like, such as area. You can only call methods on things. Okay, I got it. Totally got it. So yeah, so it's like in the object threading. We have methods into objects, and so this is just the object that can call the method. No, it's the methods which is called by the object to the object. Yeah, okay, you will get it. An example will help, so let's change our test first to call methods instead, and then fix the code. So I didn't show that, and I'm gonna try my way to do it. Okay, so I think here... Oh, did I change the display for you? Yeah, that's fine. Okay, so here, instead of doing area circle, I guess we are doing the reverse, in fact. Like circle dot area. Something like that. Seems fine, right? And same thing here. Like rectangle dot area. So we're gonna have some issues with the compiler here, with the test thing here. Undefined type rectangle has no field or methods area. Yeah, so we are gonna create these methods. Let me check that it's the right thing to do in the tutorial. What are they gonna do? Circle.area. Yeah, it's exactly the same thing. Same thing. I would like to reiterate how great the compiler is here. It is so important to take the time to slowly read the error messages you get. It will help you in the long run. Yeah, of course. So we just did it. Okay, so let's add some methods to our types. How are we gonna do this? Okay, so I'm just having a look at the syntax and it's kind of weird, guys. Okay, but I mean, why not? Okay, so we have our type rectangle here. So in order to define a method, what we're gonna do is declare function. That's weird to say, but yeah. Like, oh yes, I see why it's like that. Or rectangle. Okay, so this is the type of object we are gonna apply the method to, I think. And then area. This is the name of the method. And this is the return type returned. Okay, and what do we want to return? Like nothing, like 0.0. I think we could just write 0, but let's see. And I'm gonna do the same thing for circles. I'm pretty sure in this case the interface thing would be better, but maybe later. Okay, so here it's not a rectangle, it's a circle. and that's it. So if we run the test again, I think the message should have changed. Oh yes, it's changed. The build failed. Why did it fail? We don't know. We don't know. We don't know. We really don't know. The syntax for declaring methods is almost the same as functions, and that's because they are so similar. The only difference is the syntax of the method receiver. Okay, so guys, this thing I call the object in which we are going to apply the methods. In fact, it's called the receiver, the method receiver. So we have the function, then the method receiver, okay, with the name and the type. And after that, we have the method name, and if you want, we can put some arguments here. Okay, when your method is called on the variable of that type, you get your reference to its data via the receiver name variable. In many other programming languages, this is done implicitly, and you access the receiver via this. Oh yes, the this. Yeah, okay. It's convention in Go to have the receiver variable be the first letter of the type. Okay, so here it's not R, it should be C, I guess. But it's not that. Oh, it was. No, it wasn't. Yeah. To try to run the tests, they should now compile and give you some failing output. It's not. So let's search what did I miss. I mean, test area, fail. Oh no, it's just the test which is failing. Because we got 0 and we want something else, right? And okay, so you can see here what we were talking before, like this is just displaying some numbers but not the end of the float. Remember, the float was this one. Just a second. Yeah, this one here, line 29. That's why instead of using this formatting like 2F, they did something else, like I think it was something like J. G. Yeah, I think it was that. So if we go test, and nope, it's not that. So yeah, without the point, it would be better, I think. Oh crap. Okay, come on. Perfect. So you see now we have the whole number with all the digits. Okay, so let's continue. Yes, of course, we didn't implement, in fact, the methods. We just put a return 0. Okay, so let me check if return 0 is actually converting to float. I don't know, I'm not sure. So let's try. Okay, so it's working, kind of. You can see here we have the integer, and here, as we have just one digit, the G parameter, just put that. Okay. We should probably investigate on this formatting thing. I don't know why G is doing. But yeah, later. Let's focus on the code and try. So we just need to implement this. Like What is the area of a rectangle? It's R. What was the name of this thing again? I need to remember words, you know, vocabulary, because I'm so bad at that. The receiver. It's called the receiver. So the receiver dot width per the receiver dot a. Perfect. And for the circle, it's like, oh, it's like pi per radius squared. But how we do it get pi? Oh, great. I just had a look at the tutorial and there is a math library where you can have pi. Great, great. I love that. Obviously there is a library, but yeah, I didn't know it. But let's see that radius. Is there a math function for like square? Oh yeah, there is. Huh. Should we try it? Probably. No, this is the square root, so it's not the square thing. Like we could do something with that, but we're not gonna do some complex thing. Yeah. Not today. We are already tired enough. Okay, let's try. I like that. Okay, so the tutorial is saying that there is some duplication in our tests. What is the duplication here? What do you think? I think it's this part, like always the same. It could be always the same, I guess. All we want to do is take a collection of shapes, call the area methods on them, and then check the result. We want to be able to write some kind of check area function that we can pass both rectangles and circles to, but fail to compile if we try to pass in something that isn't a shape. Oh yes, here we are, interfaces. Great. With Go, we can codify this intent with interfaces. Such a surprise. Interfaces are a very powerful concept in statically... Maybe I can show you the tutorial for this. Yeah. Interfaces are a very powerful concept in statically typed languages like Go, because they allow you to make functions that can be used with different types and create highly decoupled code while still maintaining type safety. Okay, I like that. Let's introduce this by refactoring our tests. Okay, so we are not gonna put some interface in our test, but we are gonna prepare this to implement the interface. Where are we? Test perimeter, test area. I think we are gonna do that on area. Okay, so let's go. So they said we want to check area function. No, let me remember. We want to be able to write some kind of check area function that we can pass both rectangle and circle to. Okay, so we want a function. I just saw that, so I'm gonna write it, but I saw that on the tutorial. It's not like I know it. We can define a function like that. Check area function t So we are gonna pass the test classic thing, and then some shape, which will be of type shape. Okay, and we're gonna pass what we want also. Okay, which will be load 64. Fine. And then we're gonna define the implementation of this function, I guess. Yeah. So here we have the thelper function in the tutorial. I don't know why, honestly. T.helper. Honestly, I don't know what this is. Thelper. I don't know. Let's check this together. You know this thelper thing here? Oh, maybe it's... I don't know. Let's check together. Like t.helper go. Thelper cell different. No, that's not good. Golong, sorry. Testing thelper to make file. Result more useful. How to wrap Golong test functions. I like to wrap standard Golong test functions such as tiro for the testing package. However, when a test fails, I get the function and line of my help function. Oh, okay, I think I got it. With the recent Go, it's so recent right now, but fine. All you need to do is adding one line to your function. That will silence this function in error report, and your actual error line will be the one you expect. Oh, that's great. So, like this testing function, testing wrapped function is doing some kind of a proxy thing between our real test function and its content. If we have an error, then it will be raised into this wrapped function check area here, and we won't be able to detect where the real error is. So thanks to this t.helper, it will silence any error on the check area function itself, but it will raise any error on the content of the function. I don't know if it's clear, but let's test it, I guess. And I think you will understand. Okay, so let's go back to the code. Okay, so what we're gonna do is, I'm not gonna put this thelper thing. We will add it later. So what we got is this shape.area. What we want, we already have it here, so that's not an issue. And I'm just gonna take this, I guess, like that. Okay, that's fine. Let's run the test. And we have an issue, undefined shape. So at this point, the error is here and not into this, so the thelper things is not useful, I guess. Okay, so let's go and create this shape type, shape structure. I'm gonna put it here. So if you remember, it's type, shape, struct. And here we go. So what do we have here in this? No, it's not a struct, in fact. It's an interface. It's an interface. Okay, so it's an interface. What do we have in this interface? We have one method, which is area, that have no parameter, but it returns some float. Okay. Okay, so let's run the test. Check area declared but not used. Yeah, indeed. We didn't use the check area method function. So let's do this. How are we gonna do that? So we'll get rid of that. Yes. And that too. And here we just gonna call the check area function with some testing t, some shape. So what is the shape right now? It's the rectangle, I guess. And then what do we want? It's gonna be the want. I guess we don't need this want anymore, so I can just pass directly this. Right? Like that. Okay, I think we're fine. What the hell is here? Rectangle got declared but not used. What did I... Yeah, we don't need this either. That's it. So let's do the same thing for the circle. Like that. Okay, so I'm gonna call check area. Give it the T. Give it the circle. And then this value that I don't want to write again. Perfect. So I'm just gonna remove this. Here we are. So this should work. This should work. And the test is passing. So I love that. I love that, but as it's passing, let me change something right here. So in this case, the test should not pass. Okay, so I don't know. I would say I was thinking that we had some issue with the thelper method, but we don't. So I'm just gonna add it and we will see later if we can see why it's working or not. Like if I run the test again, yeah, it's working. And if I change a little bit things here, let's see. In this case it's failing, but yeah, nothing changed, so I don't know. We will see that later, probably. Okay, so we created this helper function, check area, and we're kind of happy. If you try to call this with something that isn't shape, then it will not compile. Yeah, it won't compile because we defined this shape thing here. So if we pass, I don't know what, maybe an integer or something else, it won't compile. Yeah. So then how does something become a shape? We just tell Go that a shape is using an interface declaration. We are creating a new type, just like we did with the rectangle, blah, blah, blah. Yes, but it's an interface rather than a struct. So that's exactly what we did. Once you add this to the code, the tests will pass. Wait, what? This is quite different to the interfaces in most other programming languages. Normally, you have to write code to say my type foo implements interface bar. Yeah, I was just kind of surprised to see that it worked. Yeah, because we never said that this type rectangle implements the shape interface. But I guess because rectangle has some kind of area method, then it's matching with the shape, I guess. So let's read what's in the tutorial. This is quite different to interface, blah blah blah, but in our case, rectangle has a method called area that returns float, so it satisfies the shape interface. Okay, so that was what I was saying. In Go interface, resolution is implicit. If the type you pass in matches what the interface is asking for. Oh, sorry. If the type you pass in matches what the interface is asking for, it will compile. Okay, I got it. Decoupling. Notice how our helper does not need to concern itself with whether the shape is a rectangle or a circle or triangle. Yeah, exactly. By declaring an interface, the helper is decoupled from the concrete types and just has the method it needs to do its job. Yeah, I love this decoupled thing. I love decoupling, and in every architecture I'm working on, I love that. Great that we can do that in Go. I would be surprised that we couldn't, but again, it's a thing, at least. This kind of approach of using interfaces to declare only what you need is very important in software design, yeah. And it will be covered in more details in later sections. Okay, great. So let's do some further refactoring. What we need to refactor? I think we're gonna go for this refactoring and then we're gonna cut this here because it's kind of late here. Now that you have some understanding of the structs, we can introduce table-driven tests. What is that? Table-driven tests are useful when you want to build a list of test cases that can be tested in the same manner. Oh. Oh, okay, I see. I see where we are going. So let's just implement that. So we have our test area here. We have I see. So let's go for it. So area test. Basically what we're gonna do is doing a list of all our test cases to be able to execute different tests in the same test function, sorry. I should not say the term methods anymore for this kind of thing. I'm sorry. Area test, what will it be? It will be a struct. Here we are creating an anonymous structure because we don't put a name in front of it. Of shape. We're gonna put in it the shape and what we want, because in fact it's exactly the model. If you have a look here at what we want is a shape and a want float. This testing is common, so that's not an issue, but yeah, okay, so we want this. So we just created that. And I think, oh yeah, I see. So we created this structure, this table of structure, and we're gonna populate this with some values, in fact. Okay, so values are, remember that we have a table here, an array. So we are here in the structure and here in the array. No, sorry, we are in the array, and here we are gonna define the structure. So the structure for this one is gonna be rectangle as the shape. Remember that to the rectangle we should pass, we should give it some width and height, I guess, which are all float. So I guess as we want some float in the definition of the structure, it will convert them. I said that because I'm seeing the tutorial and they didn't put like the .0 thing here. So I'm pretty confident about the conversion being done by itself. Okay, so we want that. And then we should give it what we want. And for this, they put the 0, so I don't know. We will see how it's gonna go. Okay, so for the second one, we want a circle. What is the circle radius? 10. 10.0. And then what we want is this big number. Where is it? Here it is. Okay, so this big number, where are we? Here. I love this way of doing things, really. Okay, and so here basically we are gonna do, oh, what's wrong? What's wrong, guys? Cannot convert 10 to type circle. What? Again, I did it again, guys. Oops, I did it again. Yeah, for structure it's like that. It's not parentheses. I won't do it again. Or maybe I will do it again just to be able to say, oops, I did it again. Okay, so now we are just gonna do a for loop to be able, in fact, to iterate through this thing. Okay, so how are we gonna do that? Okay, so let's do this. Td equal to the test specific test case table test range area test. You remember how we do for loops? We could do the classic way, but I mean this is like a for each in other languages. In fact, you know, like we could do right that like for each like area test dot for each, and then pass some have tt with a lambda assertion and blah blah blah. Okay, this is kind of the same thing, in fact, same thing. Yeah, so what we're gonna do here is we're gonna define this got variable. What we got is tt dot want. What I'm doing, sorry, is tt dot shape dot area. Yeah, that's better. Yes, thank you. So, and then here we still have our if got blah blah then blah blah. Okay, yes. This is tt.want. Find want. Here is tt.want. Okay. Don't remember to save before checking the errors because, yeah, I did 0. Okay, and we should be fine with that, I think. We don't need this anymore. Man, this is not that. This is J, G, and G here also. Yeah. So I guess we can just like, yes, we can put all that in comment. Oh crap, I'm sorry. Mac keyboard, macOS keyboard. So what they are saying in the tutorial, the only new syntax here is creating an anonymous struct area tests. We're declaring a slice of struct by using structs. Yeah. Did I say an array before? Shame on me. This is a slide, clearly. Then we fill the slice with cases. We then iterate over them just like we do any other slice using the struct fields to run our test. Okay. You can see how it would be very easy for a developer to introduce a new shape, implement area, and then add it to the test cases. Yes, exactly. Like if we want to add a triangle, it would be so easy. In addition, if a bug is found with area, it is very easy to add a new test case to exercise it before fixing it. I like that. Table-based tests can be a great item in your toolbox, but be sure that you have a need for the extra noise in the tests. If you wish to test various implementation of an interface, or if the data being passed into a function has a lot of different requirements that need testing, then they are great fits. Yeah. Exactly. Yeah, that's right. It's not so clear if it's just a simple test. You probably don't need this, but if you have a lot of different cases, and yeah, this kind of test is a perfect example, I think. Yeah. Let's demonstrate all this by adding another shape and testing it. A triangle. Okay, so yeah, I guessed the next topic. So I think we are gonna write this triangle probably tomorrow. Yeah, I'm kind of tired right now, so yeah, I'm just gonna commit this, and tomorrow we will do that. Yeah, so thank you guys for watching. I hope it's useful for you. I really like this code language, so I hope you too enjoy the way we learn that. That's it for today, and maybe tomorrow we will continue this. That's good because we will have the night to sleep over this concept, interface concept, and then we will be back tomorrow to check our knowledge doing the triangle implementation, and probably we will do that as an exercise. So thank you guys for stepping by, and see you tomorrow, I guess. Bye bye.